Okay, we're back. I didn't realize that there was a time limit on besides these videos, so I just finished this when it stopped. But I want to do a couple more real quick. So this is the first one. How about let's find the equation for this graph. First step is this going to be a cosine or a sine? Well, what happens at 0? 0, it's at 0 and it comes up. This happens for a sine. So we'll just go up here and we'll say we know this is going to be y equals a sine omega x. Amplitude's always pretty easy, right? Looks like it goes from -2 to 2. I'll just right away say A is going to be 2. Now it usually takes a little bit of work to figure out the omega. Once again, if I know the period t, then I can find my omega. So let's figure out the period. So here, I'm at the midway point heading up. I'm here at 0, so I go up, down, down, I come back up again, and I pass through 0. So it looks like the period is from 0 to 2 pi. Looks like the period is 2 pi. Therefore, omega is 1. Looks like, this is pretty simple, the graph of this curve is y equals 2 sine x. Wow. All right, I got a few more here. We can go through these fairly quickly. All right, looking at this one, once again, what's happening at 0? Here's one that's a little tricky because, oh no, we're good. This is another cosine. I was just confused for a minute. Amplitude looks like it's going to be 4. So I can figure out omega. I know omega is 2 pi over the period. Let's figure out the period. Starting here, I go down and I'm back up at the top here. Looks like I go from 0 to 4 pi. Looks like t equals 4 pi. The period's 4 pi. So omega 2 pi over 4 pi looks like 1/2. For cosine 1/2 x. So really, not too difficult. I think maybe the rest of these are all about the same. Now let me mention a couple things that you're going to be asked about on your homework that might be confusing. On these problems where they give you an equation, let me go back to my notes. This one, we said y equals 2 cosine 2x, and we figured out how to graph it. What they're going to do in the homework is, once you do this, they're going to ask you some questions. The one they always keep asking over again, they ask for the domain. And the range. Now, domain and range for a graph is pretty simple. If you recall from algebra, the domain has to do with the values of x. The range has to do with values of y. So in a graph, it's very simple. What the domain is, the domain says, for this graph, assuming the graph is continuous, there's no breaks or no jumps, the domain is, what's the smallest value of x for this graph, and what's the largest value of x? So for instance, when we graph 2 cosine 2x, here's our graph. X, right, is across here. And we know this graph actually goes on forever and ever. It never stops. So if I were to ask you how far, what's the smallest value of x for this graph? How far to the left does this graph go? Well, you know what it does? It goes on forever. Whoops. You would really say the smallest value is negative infinity. And then if I say how far now, what's the largest value of x? How far does this graph go to the right? Well, it goes on forever, which means it goes to infinity. So for this graph, you would say the domain, written as an interval, parenthesis, negative infinity, comma, to infinity, right? Interval notation. Negative infinity to infinity. How about the range? The range is up and down. The idea is what's the highest point? What's the highest point that this graph goes to? And then what's the lowest point? You actually start with the lowest. I should start with the lowest. You go from low to high. So you look at this graph. What's the lowest point that this graph gets to? Well, the farthest down it goes is to -2. And then what's the highest it ever gets to? Well, it gets to 2. So we say the range is from -2 to 2. So we would go here and we would say for this graph, the range. Now, in this case, we put brackets because actually the graph actually touches 2 and -2. Up here, when you have infinities, you can never touch infinity, so it's always parentheses. But in this case, we would say -2 to 2. Let's take another quick example. How about, well, here's a fun. How about the one where we had the vertical shift? That's sort of interesting. Remember this one? We graphed 3 cosine 4x plus 2. Let's find the domain and range. Well, first of all, the domain is the values of x. How far to the left does this graph go? Well, it goes on forever. So it goes clear out to minus infinity. How far to the right does it go? So the domain, let me just say for this one, this was our equation. But the range is interesting because the range is the up and down. So what's the lowest? What's the lowest value this goes? Well, we didn't show it here, but basically this original graph was -3, and we moved it up 2. That means the bottom of this graph ended up being at -1. So it must go from -1, and the highest point is here and here. You can see I wrote it here, 5. So it must go from -1 to 5 with brackets. All right, so not too difficult. I'm just quickly looking through the homework. See if there are any other kinds of questions that well, I can't cover everything, so hopefully whatever I haven't covered, you can always look in your book or get help in other places. All right, so that finishes up Module 3.